integrator. Op-amp as an integrator. For this, I am again using 741, 7th pin positive bias, 4th pin negative bias, 6th pin output, and 2 inverting and 3 non-inverting. I am simply ground to 3. I am taking a resistor R. I am giving a supply voltage AC signal to Vs. Another one is I am giving a feedback as capacitor. This is the basic difference. Earlier used to in inverting and non-inverting used to connect a resistor, but I am taking a capacitor as a feedback. In between, I am separating the resistor as well as capacitor by a virtual ground. Nothing but this is a circuit, virtual ground representation for integrator. In this, I am giving a square as input. It is used to generate triangular as output. Okay. The another symbol, nothing but integrator. You are applying input Vin. We are measuring output Vout. That's the basic symbol, and you can write the definition. Output is the integral multiple of input. It is also known as low pass filter. It is used to select the components for low frequency input signal. Okay, if time along x-axis and input voltage along the axis, nothing but DC. Next, we are getting an output as time, nothing but Vin, nothing but like that. It is used to generate ramp pulses. That is the basic integrator. In integrator, we are seeing the C, nothing but as a feedback, nothing but reactance of capacitor, nothing but 1 by j omega C. Nothing but it can be written as 1 by SC, where SC is equal to j omega, nothing but Laplace notation. Okay, flowing a current in the resistor R1, flowing a current is I1, and at feedback flowing a current IF. Okay, for that I am giving the simple solution for the equation. Okay, I1 is equal to IF. I1 means V1 by R1, whereas is V0 by XC. Nothing but minus V0 divided by 1 by j omega C. Nothing but minus V0 divided by 1 by SC. Okay, V0 is equal to minus 1 by RC into V1. That's RC into V1. This is by applying time domain to the above equation. We can write as output V0 is equal to minus 1 by RC integral of V1 of t dt. Nothing but output voltage is integral multiple of input voltage. At a time, it may be used in closed loop control applications, control systems, mainly applications. It may be used in triangular or a ramp generator, whereas it can be used as A to D converters, and then one it can be used as PID controllers. Okay, this is about integrator. output voltage is into it by adding another resistor across the capacitor like that. It can be also known as a active low pass filter. Frequency and gain. Okay. Another one I used to discuss important, that is differentiator. Differentiator means having also a basic symbol. Input, they are measuring output like that. I am taking the integrator. I mean taking the integrator by interchanging the components. By interchanging the components R and C in integrator, we can obtain differentiator, or we can write the mathematical reverse operation of an integrator. Okay. Another one is I am taking the capacitor over here. I am simply placing the resistor over here as a feedback and applying AC signal and non-inverting terminal is been grounded. Another same 7th positive bias, 4th into bias, 6th in output, as another one is 2, 3. Again this circuit I am redrawing virtual ground like that and applying input V in and measuring the output at the V naught. Okay, this is by interchanging the components R and C in integrator, we can obtain differentiator. The non-inverting terminal has been grounded, a AC signal is applied to inverting terminal, a feedback is connected from output to input. This is the nothing but differentiator. In differentiator, the reactance of a capacitor at low frequency, the reactance of a capacitor is high, but we are used to provide a low gain. At high frequency, the reactance of a capacitor is low, but it is used to provide high gain. Nothing but it is in this also, it acts as high pass filter, and it is used to select high frequency components for input signal. It is also basic definition having the output is proportional to differentiation of input voltage. Okay, for that I am taking the current I. It is a ratio of charge per time. Already you know that capacitor C is equal to Q by Vs, that is equal to Q is equal to CVS. The output voltage across V naught, nothing but minus IR, I already known, nothing but dq by dt into R. Again I am substituting Q, nothing but R into D into CVS divided by dt. I am moving the C to back, nothing but C into dVs divided by dt. Okay, V naught is equal to, okay, so therefore this can be written as a this can be written as a can be initialized as a K, so that K into dVs by dt. Nothing but voltage gain V naught by Vi, that is equal to output. This is the simple voltage gain. Therefore, output voltage is directly proportional to differentiation of input voltage. Nothing but differentiator. Okay. Even differentiator, if you give a square as an input, it is used to generate spikes. Nothing but input is square, output it is used to generate spikes. Okay, that is nothing but differentiator. Thank you for listening.